morning, sir.
Yes, good morning, sir. Yeah, we are talking about magnetic properties. Magnetic properties. వచ్చారా సార్ పిల్లలు ఎంతమంది వచ్చారు సార్?
జాయిన్ అవుతున్నారు సార్.
ఓకే సార్, టైం అయిపోయింది సార్, ఎందుకంటే మళ్ళీ సిలబస్ ఉన్నది సార్, ఇది కంప్లీట్ కావాలి. యా, magnetic properties. So compounds are classified into three types based on their behavior when they are kept close to a magnet. Like they are called as diamagnetic compounds, paramagnetic compounds, and ferromagnetic compounds. So if you place a substance in external magnetic field, based on their behavior, this classification is being done. So diamagnetic compounds are repelled by the magnet. They are attracted by the magnet. They are attracted, repelled by magnetic field. And they are attracted by magnetic field. And ferromagnetic substances are strongly attracted by magnetic field. So these are the basis of magnetic properties, right? Diamagnetic substances are repelled, or they don't show any attraction or repulsion with them, so most of the time they repel. And the paramagnetic compounds are attracted by it but weakly. Ferromagnetic substances are strongly attracted by it, right? So first we will talk about diamagnetic compounds. In terms of d Bloch elements, so diamagnetic substances are those substances which don't have, that means what I can say that, so the compounds with the D10 configuration are diamagnetic. Compounds of D10 configuration are diamagnetic in nature. We have seen the elements which have got this D10 configuration. Do you remember? Right? So D10 configuration is, examples cheppandamma, okati zinc, cadmium, mercury, Cn, right? So these are purely diamagnetic substances. Copper plus D10 configuration, silver plus is also D10 configuration, right? Palladium has got the D10 configuration. Even the gold has got, gold Au plus has got this kind of structure. That's why the silver and gold are not attracted by the magnet. You can check your gold ornament, gold ring. If you take a gold ring and check it with the magnet, so it is not attracted by it. It is not attracted by gold ring is best example for this. All silver ornaments also don't show any behavior towards the magnetic property. So this is D10 configuration. So all compounds with D10 configuration, or you can say D0 configuration, also fall into diamagnetic substances, right? Why? Because in all diamagnetic compounds, all electrons are paired. Right? We know that electron is a charged particle, right? Electron is a charged particle. So when it spins clockwise or anti-clockwise, when a charged particle spins around itself, so there is a creation of the magnetic field across this, around it, right? So this type of magnetic lines are being produced by a charged particle, that is electron. Charged electron when spins, so they have spin plus half and minus of spins are there. So that's why when they spin, they create the magnetic field. But if you have two electrons which are paired up, for example, this is the electron with plus half spin and this is the electron with minus half spin. This is with the minus half spin. The magnetism created by this electron is cancelled by magnetism created by the other electron. So that's why there is magnetic field, but all these magnetic fields operate in opposite direction. That's why all of them cancel out each other. They cancel out each other. All of them cancel out each other. So therefore, they cancel out. They cancel each other. That's why they don't behave, they don't attracted by the magnetic substances, right? So all these are the diamagnetic substances. Diamagnetic substances are repelled by the external magnetic field, right? So all you need to know is D10 configuration and D0 configuration, right? సో క్వశ్చన్స్ డైరెక్ట్ అడిగితే డైరెక్ట్ ఉంటుందమ్మా, ఇండైరెక్ట్గా అడగాలి అంటే ఇండైరెక్ట్గా అడగవచ్చు, రైట్? ఫర్ ఎగ్జాంపుల్ క్వశ్చన్ ఎలా వేస్తాడు అంటే, సో విల్ టేక్ వన్ ఎగ్జాంపుల్ హియర్. ఐ గాట్ కాపర్, right, I got copper plus 2. So which of the following is diamagnetic? Now you have to write the electronic configuration. Copper electron configuration, we know that 4s1 3d10. So it has d10 configuration, that's why it's diamagnetic. Copper plus 1 is 4s0 3d10, still it's diamagnet. Whereas copper plus 2 has got 3d9 configuration. So it has got one unpaired electron, that's why it is not a diamagnetic substance. You got 4 pairs of electrons and one electron here, so due to which the copper plus behaves like a paramagnetic substance. So these electrons cancel out their magnetism, these electrons also cancel out each other, these electrons also cancel out each other, these electrons also cancel out, but this electrons magnetism isn't neutralized because it is not paired. So therefore copper plus 2 behaves like a paramagnetic substance, right? So you will be asked questions like, you will be given a compound or ion and you asked which one is the paramagnetic or diamagnetic. Now we will talk about paramagnetic substances. Paramagnetic substances or metals. In paramagnetic metals, they are weakly attracted by, they are weakly attracted by the magnetic field. So these are attracted, but these are also weakly attracted by these compounds. So they are not attracted so strongly, so they are attracted. So they are attracted by the magnetic field. Attracted by magnetic field. So here the electronic configurations corresponding to this paramagnetism is 1, D1, D2, D3, D4, right? So D5, D6, D7, D8, D9 and the D10 we should not include. So D10 cut karna hai, even the D0 bhi aapko cut karna hai. So these are the middle ones are the responsible for paramagnetic behavior. How exactly they behavior like that? Why? Varna sir evaradi? అమ్మ ఎవరో అన్మ్యూట్ చేసుకోండి అమ్మా. ఓకే, రైట్. సో యూ షుడ్ లుక్ ఫర్ దీస్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్. హౌ డు యూ లుక్ ఫర్ దీస్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్? ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్ రాయాలి, దెన్ యూ గో ఫర్ ద బాక్స్ మెథడ్లో డిస్ట్రిబ్యూట్ చేయాలి, then you will come to know which one is paramagnetic, which one is diamagnetic. Yeah, as simple as that, isn't it? So it is very simple. Just you have to look at the electronic configurations, right? Paramagnetic and ferromagnetic. ఇందులో చూడండి, so I'll write the D1 configuration boxలో. So 1 2 3 4 5. So there is, so इसको कॉपी करता हूँ मैंने, कॉपी क्यों नहीं होता है? You can only move it, oh, correct. So you have one D1 configuration here. There is one configuration, that is D1 configuration is here. So in D2 case, so you got 2 unpaired electrons. In D3 case, you got 3 unpaired electrons, 1 2 3, right? ఒకటి ఎక్కువ అయిపోయింది, ఇవన్నీ బాక్సులు బాగా వస్తలేవమ్మా. ఒకటి 2 3 4 5 6 7 8 సరిపోతాయి, రైట్? Right. So we distribute the electrons here. So you got 1 2 3 4 5. So 1 2 3 4 5, right? Here also I can draw a straight line. So 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. చెప్పండి అమ్మా, ఎలక్ట్రాన్ డిస్ట్రిబ్యూషన్స్ చెప్పాలి ఇప్పుడు. సో యూ హ్యావ్ టు డిస్ట్రిబ్యూట్ ద ఎలక్ట్రాన్స్. సో లెట్ us talk about D1, 1 electron, D2, 2 unpaired electrons, D3, 3 unpaired electrons, D4, 4 unpaired electrons, right? So D5, so 5 unpaired electrons. But when it comes to D6, so one of the electron gets paired up, 5 unpaired electrons and 6th one goes for pairing. And D7 configuration, 1 2 3 4 5, this is 6, this is 7th one. So this is 1 2. D8 configuration, 2 3 4 5 6 7 8, right? We need one more. So D9 కూడా కావాలి కదా, we need D9 also, right? So D9 is going to be like this. So here is 1 2 3 4 5 6 7 8 9. So number of unpaired electron is 1 here, number of unpaired electron is 2 here, number of electrons are 3 here, unpaired electrons are 4 here, number of unpaired electrons are 5, but here 6 అమ్మ, మళ్ళీ 6కి వచ్చింది చూడండి. 6కి వచ్చేసరికి 4 అయ్యింది, ఎందుకంటే వన్ ఆఫ్ ద ఎలక్ట్రాన్ హ్యాస్ గాట్ పేర్డ్. సో దిస్ ఈజ్ 3 and this is 2 and this is only 1, right? So we can also quantify the magnetic property by using the formula mu equal to under root n into n plus 2 formula use करके will get in Bohr magnetons. Using this formula you can also calculate the magnetic momentum of these compounds, right? సో ఫస్ట్ గుర్తుపెట్టుకోవాల్సింది ఏంటంటే 1 to 5 గుర్తుపెట్టుకోవాలి, మళ్ళీ 6 నుంచి మళ్ళీ తగ్గిద్ది, ఇక్కడ డిసెండింగ్ ఆర్డర్లో వస్తుంది, రైట్. ఇక్కడ 6కు n = 6 తీసుకోకూడదు. సో ఇక్కడ n = 1, ఇక్కడ n = 5. సో యూ కెన్ టేక్ ఇట్. సో ఇక్కడ ఏం చేస్తాను చెప్పండి. సో హౌ డు యూ క్యాలిక్యులేట్ దిస్? సో దిస్ ఈజ్ అండర్ రూట్ 1 into 1 plus 2. సో విచ్ ఈజ్ రూట్ ఎంత వస్తుందమ్మా? 3. సో హియర్ ఇట్ ఈస్ గోయింగ్ టు బి 2 into 2 plus 2. సో విచ్ ఈస్ గోయింగ్ టు బి 2 2s are 4, 4 2s are 8, root 8. So here it is going to be 3 into 3 plus 2. So 5 3s are 15, it corresponds to root 15. And here it is 4 into 4 plus 2. So this corresponds to how much? So this is 6, 6 4s are 24. Right? So when it is 5, what can you take? So root 5 into 5 plus 2. 7 5s are 35, root 35. Again you correspond to 4 here. So ikkada malli em chestam? Root 4 times 4 plus 2. So which is root 24. So here 3 into 3 plus 2. So again root 15. So this is going to be root 2 into 2 plus 2. So root 2, 2 2s are 4, 4 2s are root 8. So this is root 3 వస్తుంది. చూడండి, you have to write the electronic configuration of a ion, you have to find the unpaired electrons, and you should calculate this magnetic momentum. Magnetic momentum of the compound आपको लिखना है. Only we consider this is from d orbital से ही consider करना होगा. s orbital का we generally don't consider. Only d electrons you have to consider, and you can quantify this one. So this is Bohr magnetons. Bm stands for Bohr magnetons. Right, we'll see few examples. Right, so what examples we'll start with? We start with an element. कहाँ से शुरू करेंगे? या ఏదైనా ఒక ఎలిమెంట్ తీసుకుందాము. ఫర్ ఎగ్జాంపుల్ ఎలిమెంట్ ఎలక్ట్రాన్ కాన్ఫిగరేషన్ ఈజ్ 4s2 3d6 ఉంది. ఆఫ్ కోర్స్ దిస్ ఈజ్ ఫర్ ఐరన్, రైట్. సో ఐరన్ के लिए मैग्नेटिक मोमेंटम ఎంత వస్తుందో చెప్పండి ఇప్పుడు, క్యాలిక్యులేట్ చేసి యూ కెన్ చెక్ ఇట్. If you have 6 electrons, how many unpaired electrons are there? 4. So your n equal to 4. So what is the formula here? Mu equals to under root n into n plus 2. So this is the formula. So if you plug in here, so 4 into 6, correct? So this is root 24. Okay, so root 24. Otherwise I'll tell you the best method to remember. If your n value is 1 2 3 4 5, that's it. 6 ఉండదమ్మ, ఇక 6 ఉండదు, 7 ఉండదు, 8 కూడా ఉండదు, 9 కూడా ఉండదు, 10 కూడా ఉండదు. 0 ఉంటే 0 అని చెప్తాం, 0 ఉంటే 0 అంటుంది, రైట్. సో ఇఫ్ దిస్ ఈజ్ ద కేస్, సో ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేద్దాం. n ఇంటూ n ప్లస్ 2. సో దట్ ఈస్ n ఇంటూ n ప్లస్ 2లో సబ్స్టిట్యూట్ చేద్దాం. సో ఇక్కడ ఎంత వస్తుందో చెప్పండి, రూట్ 3 వస్తుంది, రైట్. రూట్ 3ని సాల్వ్ చేస్తే ఎంత వస్తుందమ్మా? 1.73 బోర్ మ్యాగ్నెటన్స్ వస్తుంది. ఇక్కడ ఒకటి గమనించు. సో ఇక్కడ ఎంత వస్తుంది? రూట్ 2 అయితే ఎంత వస్తుందమ్మా? 8 వచ్చింది, రైట్. రూట్ 8. సో 3 అయితే ఎంత వచ్చింది? రూట్ 15 వచ్చింది. 4 అయితే రూట్ 24 వచ్చింది. 5 అయితే రూట్ 35 వచ్చింది, రైట్. సో దీస్ ఆర్ ద వాల్యూస్ యూ షుడ్ రిమెంబర్. ఎన్ని ఉన్నాయా మేబీ? ఓన్లీ 5 ఆర్ దేర్. వై యూ డోంట్ హ్యావ్ దీస్ వన్స్, దట్స్ వై इसको डिलीट कर देता हूँ मैंने. ఓన్లీ దీస్ వన్స్ ఆర్ దేర్. సో ఇక్కడ So root 8, how do you solve root 8? You know root 9, right? Root 9 is how much? Exactly 3. Root 8 ను గెస్ చేయండి, 3 కంటే తక్కువ వస్తుంది అంతేనా? So therefore, so you can write it like 2.7 and 2.6. Root 16 ఎంతమ్మా? 4 కదా, ఇది 4. Root 15 ఎంత రాస్తారు? Root 15 would be how much? So 3.8 or 9. So you can write it as 3.8. Root 25 is how much? 5, right? But you have root 24, right? Will be 4.9. So ఇక్కడ ఎంత వస్తుందండి? 4.9 వస్తుంది. So root 36 is 6. Everybody knows it. So root 35 would be 5.9. So ऐसा कुछ होगा value, right? It's easy to remember, right? So you can remember is you can relate these ones with these numbers. ఇక్కడ ఉన్న నంబర్స్ తోటి ఈ వాల్యూస్ తోటి మీరు కనెక్ట్ చేస్తూ చేయాలమ్మా. ఈజీగా ఉంటుంది, ఇలా ఏమి ఉండదు అట్లా, రైట్? సో ఇక్కడ ఎన్ వాల్యూ ఇవ్వడండి తను. ఎన్ వాల్యూకు బదులు హీ గివ్స్ యూ ఎన్ ఎలిమెంట్ ఆర్ ఎన్ అయాన్. देन यू हैव टू फाइंड इट, राइट? आपका आंसर तो इसी में से होना चाहिए एक. योर आंसर वुड बी फ्रॉम वन ऑफ दिस ओनली ఆర్ దిస్ వన్. దీన్ని సాల్వ్ చేస్తే ఇది వస్తుంది, లేదంటే ఇది వస్తుంది. ఇంకోటి, ఇక్కడ 1 ఉంటే ఇక్కడ 1 పాయింట్ వస్తుందండి, ఇక్కడ 2 ఉంటే 2 పాయింట్ వస్తుంది, ఇక్కడ 3 ఉంటే 3 పాయింట్ వస్తుంది, 4 ఉంటే 4 పాయింట్ వస్తుంది, 5 ఉంటే 5 పాయింట్ వస్తుంది, రైట్? ఎగ్జాక్ట్లీ ద సేమే వస్తుంది. సో లెట్ us టేక్ అప్ few questions, right? So like what we take here, we take cobalt +2, right? You have to write the electronic configuration of cobalt +2, cobalt +3, then we match it. Cobalt రాద్దాం, చెప్పండి. cobalt 27, right? So it is 4s2 3d7, right? So 7 means how many pairs and how many unpaired electrons? బాక్స్ మెథడ్లో రాయొచ్చు. 1 2 3 4 5. So 6 goes for pairing, 7th goes for pairing. 3 electrons are there, right? So 3 unpaired electrons are here. So this matches with 3 unpaired electrons అయితే దీంతో మ్యాచ్ కావాలి, దీంతో మ్యాచ్ అవుతుంది. కోబాల్ట్ +2 కూడా దీంతో మ్యాచ్ అవుతుంది. 4s0 3d7. So this also matches with this because we haven't used anything here. But when it comes to cobalt +3, so it is 4s0 3d6. So this 6 corresponds to how many unpaired electrons? I think 4 unpaired electrons. 1 2 3 4 5 6. So you got 1 2 3 4 unpaired electrons are 4. So it corresponds to, సో ఇక్కడ నుంచి ఇక్కడికి 14 root 49, ఇక్కడికి ఈ విధంగా యూ కెన్ మ్యాచ్ ఇట్. ఎనీ ఎలిమెంట్ కాంపౌండ్ ఈజ్ గివెన్ టు యూ, యూ కెన్ డూ దట్. ఓకే, సో లెట్ us టేక్ వన్ మోర్ ఎగ్జాంపుల్. Fe +2, Fe +3. చెప్పండి. Fe ఈజ్ 4s2 3d6. 6 అంటే 4, సో 4.9. So this also 4s0 3d6. So this also 4.9 or root 24, and Fe +3 4s0 3d5. So this corresponds to root 35. Root 35, yeah, 5 unpaired electrons are there, therefore 5.9. లేకిన్ 5.9 మీరు ఆన్సర్ వస్తే దీన్ని 6గా చేయాల్సి వస్తుందమ్మా. ఎంసెట్లో కాదు కానీ ఇలా మెయిన్స్లో మాత్రం you have to make it as a 6, right? So this is how the questions are generally asked. So these are the magnetic properties, right? We'll go to the next property, that is formation of colored complexes. Formation of colored complexes by these group elements. Yeah, D block elements form colored complexes. Why do they form like that? We will discuss, right? So the formation of color, right? So colors are, when can you see the colors? Only in presence of light you can see the colors, right? Colors are invisible during the night. Everything looks dark during the night, but you need light. ఆ లైట్ కూడా సన్లైట్ ఇది కావాలి. సో ఇన్ ప్రజెన్స్ ఆఫ్ సన్లైట్ ఓన్లీ వీ కెన్ చెక్ ద కలర్స్, రైట్? సో హియర్ we have got d orbitals. So formation of colored complexes are by all paramagnetic substances. All paramagnetic या ferromagnetic substances are colorful, and all diamagnetic substances are colorless. They are colorless. Now we can relate it to our electronic configuration. If you have D0 configuration and D10 configuration, all electrons are paired here. All electrons are paired. These ones are colorless. They don't show any color. But electronic configurations corresponding to D1, D2, D3, D4, D5, D6, D7, D8, D9. So these electronic configurations are responsible for the color of the complexes, right? So all I can say that D block compound, so D block element, so D block element with at least one unpaired electron. One unpaired electron shows the color. Why is it shows the colors? Right, I'll explain here. Actually, D subshell has got 5 orbitals like dxy, dyz, dzx, dx squared, y squared, dz squared. Here the first 3 have got their electron densities between the axes. So here they have along the axis. That's why when d orbitals are 5 d orbitals, generally they go split in presence of sunlight. They split like this. So 2 orbitals are here, and here you have 3 orbitals, right? So splitting of d orbitals takes place in presence of sunlight ke presence mein they dissociate like this. So if you have got one electron here, in presence of sunlight, this electron can jump from lower energy orbit to higher energy orbit, and higher energy orbit to lower energy orbit. It can transit. This is what you call it as DD transit. So when this energy of this is lowest, energy of this is higher. So when electron jumps from lower energy to higher energy, it absorbs the energy which is supplied by the visible light of the spectrum, whose wavelength ranges from 400 to 700 nanometers. This energy, the visible light energy, is enough to jump this electron from here to here. But when this electron going back home has to emit the energy, so it has to emit the absorbed energy. So when an element or any substance, it absorbs sunlight and releases sunlight, so it will be colorful, right? So this DD transition is possible in all these configurations, D1 to D9 configurations. This is possible. In D10 configuration, let us check about the D10 configuration. If you have D10 configuration, there is a problem. Why there is a problem, you can check here. So if you have D10 configuration, చూడండి ఇక్కడ 1 2 3 4 5 6 7 8 9 10 you have full, this is full and this is also full. That's why they can't exchange here. DD transition is not possible in D10 configuration. So that is why there is no possibility of colored complexes by this D10 configuration elements. And D0, they don't have any electron and they don't show any colors at all. Right? So these are other two important properties of D block elements. Right, here is the magnetic property. So when magnetic field applied to a substance, mainly two types of magnetic behaviors are observed, diamagnetism and paramagnetism. Diamagnetism substances are repelled by applied field while paramagnetic substances are attracted. The substances which are attracted very strongly are said to be ferromagnetic. In fact, ferromagnetism is an extreme form of paramagnetism. Many of the transition metal ions are paramagnetic in nature. The paramagnetism arises from presence of unpaired electrons, each electron having magnetic momentum associated with its spin angular momentum and orbital angular momentum. Right? So for the compounds of the first series of transition metals, the contribution of orbital angular momentum is affected by quenched and hence no significance for these ones. So angular momentum is not that effective, that's why we ignore this one. Actually magnetic momentum corresponds to both L and N, రెండిటికి వస్తుంది. So this is also calculated by the same formula, L into L plus 1 formula use करके you can calculate. L is most of the time it is applicable to, it is not applicable for 0 orbital, s orbital. It is very very negligible, that's why we ignore it, hence it's no significant. For this, magnetic momentum is determined by the number of unpaired electrons, calculated by using formula called as spin only formula, that is mu equals to under root n into n plus 2 Bohr magnetons. Right? So here is the question given. So scandium plus 3 D0 configuration, unpaired electrons 0, magnetic momentums are 0. Titanium plus 3 D1 configuration, so calculated 1.3, observed is also 1.75, almost same ही होता है. Titanium plus 2 3D2, so 2 electrons 2.84. Vanadium plus 2 3 unpaired electrons 3.87, 4 unpaired electrons 4.9, 5 unpaired electrons 5.9. So manganese ku D5 configuration undandi ikkada. Right? Iron is 4 4.9, 3 3.8, 2 2.8, 0 aitho 0. So this is how you calculate. మీకు ఇచ్చేటటువంటి క్వశ్చన్ ఇన్ మెయిన్స్ ఎగ్జామ్ క్వశ్చన్స్ ఆర్, these are given and you ask to calculate this one, और कभी कभी रूट वाला भी क्वेश्चन पूछेगा. सो रूट 24 या रूट 35, रूट 8, रूट 15, ये वाला क्वेश्चन भी మోస్ట్ ఆఫ్ ద టైమ్ మ్యాచ్ ద ఫాలోయింగ్ క్వశ్చన్స్ అడిగారమ్మ ఇంతకుముందు అయితే చాలాసార్లు మ్యాచ్ ద ఫాలోయింగ్ క్వశ్చన్స్ ఆర్ బీయింగ్ ఆస్క్డ్. Right. Next one, formation of the colored complexes. When an electron from lower energy d orbital is excited to higher energy d orbital, the energy of excitation corresponds to the frequency of light observed. This frequency generally lies in the visible region. The color observed corresponds to complementary colors of the light observed. The frequency of the light observed is determined by the nature of the ligand. In aqueous solutions, water molecules are ligands. The colors of the ions observed are listed below. The colored solutions of D block elements are given here. ఇక్కడ కలర్స్ ఇచ్చాడు చూడండి అమ్మా. లాస్ట్ టైం ఒక క్వశ్చన్ అడిగాడు, విచ్ ఆఫ్ ద ఫాలోయింగ్ అయాన్స్ హ్యావ్ సేమ్ కలర్ అనే ఒక క్వశ్చన్ అడిగాడు, రైట్? సో చూద్దాం ఇక్కడ. D0 కలర్లెస్ ఉండాలి చూడండి, D0 కలర్లెస్. D0 ఇది కూడా కలర్లెస్సే ఉండాలి. D10 కూడా కలర్లెస్సే ఉండాలి చూడండి, D10 కూడా కలర్లెస్సే. సో D1 టైటానియం +3 పర్పుల్ కలర్, D1 వెనీడియం బ్లూ కలర్. ఇక్కడ మీకు అర్థం కావచ్చు, రెండిటికి D1 ఉంది కదా, వై ద కలర్ హ్యాస్ బీన్ చేంజ్డ్. బట్ టైటానియం వెనీడియం హ్యాస్ గాట్ డిఫరెంట్ నెంబర్ ఆఫ్ ప్రోటాన్స్, isn't it? So that's why the excitation requires different amount of energy. That's why the color observed, the heat observed by it is different. That's why it gives you different substance. So it's as simple as that. If same ion, same configuration, the charge kuda same leduga malli chudu ikkada. You don't have the charge equal. The charges are different. That's why the color required is going to be different ones. So all these of them have got colors, right? Copper +2 blue in color, titanium purple color है, vanadium +4 blue है, ये green है, ये violet ఏంటి ఏమో మూడు ఉన్నాయి violet చూడండి. vanadium chromium manganese are violet. So chromium +2 blue, manganese +2 pink, iron +3 yellow, iron +2 green, cobalt +3 blue pink, and nickel is green. గ్రీన్లు రెండు ఉన్నాయి చూడండి, ఐరన్ +2 అండ్ దిస్ వన్ కాపర్ +2 ఈజ్ బ్లూ ఇన్ కలర్. ఒక పిక్చర్ కూడా ఇచ్చాడు చూడండి ఇక్కడ. వెనీడియం +4 కలర్ ఏంటమ్మా చెప్పండి, బ్లూ. వెనీడియం +3 color is green, blue green. So this can we call it as pink? This is pink. This is yellow, I think. Fe +3 yellow. Cobalt +2 is it red? Cobalt +2 color, yeah, is it red or pink? You can call it as pink. So this is dark blue, this is copper, and this looks like green. So these are the colors. Okay, so next and the last parts of this one are catalytic property of the D block elements, formation of interstitial compounds, and formation of alloys. So these are also we should know them. Most of the D block elements are good catalysts. Why they are catalysts? Because they have d orbitals unoccupied, empty d orbitals are present. These empty d orbitals allow the other gases to get absorbed and disadsorbed. So therefore they act like a catalyst. చదువుదాం ఇక్కడ ఏమి ఇచ్చాడు. The transition metals and their compounds are known for their catalytic activity. This activity is ascribed to their ability to adapt multiple oxidation states and formation of the complex. So ఇక్కడ ఇచ్చిన ఆన్సర్ ఏంటమ్మా, catalytic ప్రాపర్టీకి ఆన్సర్ ఇచ్చింది ఎంటీ డి ఆర్బిటాల్ కాదు, మల్టిపుల్ ఆక్సిడేషన్ నెంబర్. Multiple oxidation states is the reason for this, and to form the complexes. So vanadium 5 V2O5, that is V2O5, vanadium pentoxide, acts as a catalyst in contact process. Finely divided iron acts like a catalyst in Haber's process. Nickel is used in catalytic hydrogenation of unsaturated oils. Catalysts are solid surfaces which involve in the formation of bonds between reactant molecules and atoms of the surface of the catalyst. First row transition metals 3d 4s electrons for bonding. So this has effective increasing of concentration of the reactants at the catalyst surface also weakening of the bonds in reacting molecules, activation in lowering. Also because transition metals ions can change their oxidation states, so they become more effective catalyst. For example, iron plus 3 catalyst reacted for this reaction. So these are the examples given here. Next one, formation of interstitial compounds. So interstitial compounds are those which are formed when small atoms like hydrogen, carbon, nitrogens are trapped inside the crystal lattice structure of the metals. Metals, all atoms in the metals have spheric structures and they form these interstitial places. In these interstitial spaces, the elements like this carbon, nitrogen, hydrogen can come and trap inside these spaces, and they will give the non-stoichiometric compounds which are neither typically ionic nor they are neither ionic nor covalent. For example, TiC, Mn4n, Fe3H, vanadium hydride 0.56, titanium hydride 1.7. The formulas quoted do not of course correspond to any normal oxidation states of the metals. So these are the right. ఇక్కడ 4 manganese-కు ఒక nitrogen అతికి ఉంది అని, right? So they are not stoichiometric, they are mentioned here, they are non-stoichiometric compounds. Because of the nature of their composition, the compounds are referred as interstitial compounds. The principal physical and chemical characteristic of these compounds are given here. They have high melting points, higher than those of pure metals. They are very hard. Some borides approach near to diamond toughness, hardness. They retain metallic conductivity. They are chemically inert. ఓకే. సో మొన్న పోయినసారి నీటిలో ఈ దీని నుంచి డైరెక్ట్ క్వశ్చన్ వేస్తారమ్మా, అల్లాయిస్ ఫార్మేషన్ అంటే. అల్లాయి ఈజ్ ఏ సాలిడ్ సొల్యూషన్, బోత్ సొల్యూట్ అండ్ సాల్వెంట్ బోత్ ఆర్ సాలిడ్స్ హియర్, రైట్? అల్లాయి ఈజ్ ఏ బ్లెండ్ ఆఫ్ మెటల్స్ ప్రిపేర్డ్ బై మిక్సింగ్ components of alloy, homogeneous solid solution in which atoms of one metal are distributed randomly among the atoms of others. Such alloys are formed by atoms with metallic radii that are within 15% of each other. The similar radii of each other, कुछ examples आपको याद रखना है. The best known ferrous alloys are chromium, vanadium, tungsten, molybdenum, manganese are used for production of variety of steels and stainless steels. Alloy formation is a non-transitional metal such as brass, copper and zinc, bronze, copper, and this also considerably industrial importance. It also have got industrial importance. Some compounds we will talk about later about that, right? So what are we left with? We are left with one more point that to be noticed here about this graph, right? So this graph is important. Chala sarla questions adigaramma deen paina. So what do we talk about this graph? So here this graph gives you standard electrode potentials on y-axis and elements on the x-axis. So when they are plotted with these ones, so you have got observed values as well as calculated values. Observed and calculated values almost same ఏ ఉంటాయి. కోబాల్ట్ నికల్కి ఇక్కడ రెండింటికి మ్యాచ్ అవ్వవు అంతే, రైట్? సో ఒకసారి y-axis-ను if you check it, so the scale starts from -2, -1/2, -1, -half, 0, +half, right? So this is it, okay? So ఇప్పుడు question is, which element standard electrode potential is positive? ఒకటే ఉంటుంది చూడమ్మా, వెరీ వెరీ ఇంపార్టెంట్. సో ఇక్కడ 0 పైన ఉన్నది ఒకటే. ఈ ఎలిమెంట్ ఎవరండి? కాపర్. Copper has positive standard electrode potential, right? And the remaining ones have negative reduction potential, right? So negative standard reduction potential corresponds to reducing property. It is a reducing property होता है. The positive one represents oxidizing property. So the positive one gives you, this positive one gives you the oxidizing property, right? So ikkada copper di okati paina untadi, that you should remember. We will go through this. Table 4.4 contains thermochemical parameters related to the transformation of solid metals from M plus to M plus. Standard electrode potentials observed are given in this. The unique behavior of copper having a positive E naught value accounts for inability to liberate hydrogen from the acid. This is the point, right? ఇక్కడ ఒక ఈక్వేషన్ చెప్తా చూడండి. జింక్ వెన్ ప్లేస్డ్ ఇన్ HCl, we will get hydrogen gas and zinc chloride is formed. But if you do the same thing with copper, no reaction takes place. Reaction doesn't take place, right? So copper cannot replace the hydrogen from the metal, because hydrogen zero అమ్మా, హైడ్రోజన్ది జీరో ఉంటుంది. Zero is smaller than this copper plus 2 value, that's why. So it shows inability. ఈ క్వశ్చన్ జేఈలో అడిగారమ్మా, స్టేట్మెంట్గా ఇచ్చేసారు. The only oxidizing acids, nitric acid and sulfuric acid, react with copper, the acids being reduced. The acids are reduced, no hydrogen gas is released here. Acids are reduced, not hydrogen is reduced. The high energy of transformation of copper solid to copper aqueous is not balanced by hydration enthalpy. The general trend, less negative electrode potential values, right? So this is E naught values. Right. So we also talk about oxides and halides. Oxides and halides. Oxides and halides. So here are the table which talks about oxides of these group elements. Let us talk about what are oxides here. So oxides, oxidation numbers వస్తే oxides వస్తుందమ్మా, right? Plus 1 oxidation number is shown by only one element. Who is that? Copper. So copper CuCl మాత్రమే తెలుసు, ఇంకా వేరేది ఏది తెలియదు. Titanium plus 2 is almost all elements are forming these plus 2 compounds. Plus 3 are formed by titanium, vanadium, chromium, manganese, iron, cobalt. These are considerably, plus 3 oxidation state is stable for them. Plus 4 is shown by titanium, vanadium, chromium, manganese, right? So here ఇక్కడ ఇంకొక కీ కూడా ఇచ్చాడు, T3. This third one stands for only chlorides to iodides is known. Only one is only fluorides are known. That means vanadium tetrafluoride is known, vanadium tetrachloride is not known అన్నట్టు. Okay. So pentafluorides are only 2, chromium and vanadium. Hexafluoride is only one, that is chromium. Manganese cannot form these ones. Okay, these are the halides, right? Halides के बारे में क्या दिया है देखेंगे. The stability of halides of 3D series transition metals, the highest oxidation numbers are achieved in titanium tetrahalide, VF5 CrF6. So 4 in TiX4, 5 in VF5, 6 in CrF6. Plus 7 state for manganese is not represented as simple halide, but you will get oxyfluoride is known. So this is not, this is an oxyfluoride. So MnO3F is manganese trioxyfluoride. So oxygen manganese oxidation number is again 7 आया, यहाँ पर it is 7, right? So and beyond manganese no metal has trihalide except FeX3 and COX3. So ఇక్కడ వీటి తర్వాత ఇంకా వేరేది ఏది లేదు. ఇక్కడ నుంచి the beginner members to up to here ఇక్కడికే ఎండ్ అయిపోయింది. The ability of fluorine to stabilize the oxidation states is due to their high lattice energy in case of COF3. Higher bond enthalpy terms higher covalent bonds, example VF5, CrF6. Although VF5 represented only by VF5, the other halides however undergo hydrolysis to give oxo halides, that is VOX4, X3. Another feature of fluorides is instability in low oxidation state. Right, here we have oxides. Oxides lo chudandi okati, we know Mn2O7 which has manganese oxide. Mn2O7 lo ela undali? So both manganeses are connected by one oxygen and you have 6 oxygens connected to each oxygen. This is the structure of Mn2O7, right? So ikkada inkoka point em gurtu pettukovali ante, so these oxides are acidic oxides. ఇచ్చుంటాడు ఇక్కడ. The stability of copper plus 2 rather than copper plus is due to the much more negative delta H hydration of copper plus than the copper plus 2, which more than compensates the second ionization enthalpies of copper. The ability of oxygen to stabilize highest oxidation state demonstrates the oxides. The highest oxidation number coincides with the group number of the elements like Si2, O32, Mn2O3. Behind group 7, no higher oxidation states of Fe, Fe2O3 are known, although ferrate formed alkaline medium and these are some oxo acids are also mentioned here. This is about oxides. So chemical reactivity, magnetic properties, all these things we have seen. Now we'll go to some questions देखेंगे अभी. Right, the amphoteric oxides it is మనం చూడలేదు ఇంకా. Right, the spin only magnetic momentum value of compounds with strong oxidizer power among the following is how much? So you are given 3 compounds are given, इसका magnetic momentum calculate करना है. Right, how do we do it? Mn2O3 లో manganese oxidation number find చేయాలి, right? Mn2O3 లో manganese oxidation number is +3, right? So it is +3, so 4s2 3d5 is the manganese configuration, so it will be 4s0 3d4, so కాబట్టి 4.89 వస్తుంది. titanium +2, right? Titanium +2, so titanium 4s2 3d2, titanium +2 will be 4s0 d2, so 2 configuration ante 2.7 వేసుకో లేదా 2.8 వేసుకో. and vanadium +2, so vanadium scandium titanium vanadium తర్వాత వస్తుంది కాబట్టి 4s2 3d3, సో ఇక్కడ +2 ఉంది కాబట్టి ఇది పోయింది, ఇక్కడ ఎంత వస్తుంది 3.8 వస్తుంది. right? So this is going to be 5, this is going to be 3, this is going to be 4. But the question isn't about this one. Indulo strongest oxidizing power, the spin only magnetic momentum lo the strongest oxidizing power దేనికి ఉంటుంది చెప్పండి అమ్మా. స్ట్రాంగెస్ట్ ఆక్సిడైజింగ్ పవర్ దేనికి ఉండాలి? ఆక్సిడైజర్ టేక్స్ ఎలక్ట్రాన్, right? Oxidizer always takes the electron. If one oxidizer takes electron, so what will happen? Its oxidation number increases. So ikkada manganese పరిస్థితి చూడు ఒకసారి. D5 configuration is most stable configuration. D4 configuration is nearly approaching to D5, right? There is only one electron short of it. Only one electron short of it to get 5. So manganese plus 3 is strong oxidizing agent. So answer would be 5 hoga. ikkada chudamma, correct set of ions in aqueous solution with the same color from the following are. చూడమ్మా ఇది ఎంత టిపికల్ క్వశ్చన్. అయితే we can use कॉमन सेंस यूज करना है आपको. ఇది కలర్లెస్ అమ్మ, జింక్ కలర్లెస్, ఐరన్ గ్రీన్, ఇది లేదు ఆన్సర్. స్కాండియం +2 కలర్లెస్, ఇది కూడా కాదు. సో యూ హ్యావ్ ఓన్లీ 2 ఆప్షన్స్ లెఫ్ట్. సో ఇక్కడ మ్యాంగనీస్ +2 ఈజ్ పింక్ ఇన్ కలర్. మ్యాంగనీస్ +2 పింక్ ఇన్ కలర్. So unfortunately we can't answer this question on basis of electronic configuration. Why? Because different elements may have same configuration in their ionic state. In that case the colors are going to be different ones, right? So vanadium +2 chromium +3 రెండు ఉన్నాయి కదా. సో చూద్దాం అవి. vanadium +3 chromium +2. I think answer is B. చూడండమ్మా, ఈ టేబుల్ నుంచే ఇచ్చాడు. వెనీడియం +3 గ్రీన్, క్రోమియం +3 వాయిలెట్, వెనీడియం +2 వాయిలెట్, మ్యాంగనీస్ +3 కూడా వాయిలెట్. చూడండి ఇక్కడ నుంచి ఇచ్చిండమ్మా క్వశ్చన్. వావ్, ఎన్సీఆర్టీని లైన్ టు లైన్ చదివి నోటి చేస్తాడు, లేకపోతే పెద్ద పెద్ద మహానుభావులు కూడా బోర్ల పడతారు ఇక్కడ. Why? Because the same color is in here only. Vanadium, chromium, manganese have got same colors with their these oxidation numbers, right? So Mn+3 color entama, Mn+3 violet, Mn+2 pink, right? What is given here? Vanadium +4 is blue. Okay, so ఇది ఐడియా ఉంటే వస్తుందమ్మా, లేకపోతే రాదు. చూడండి, దిస్ మ్యాచ్ ద ఫాలోయింగ్ క్వశ్చన్. 12th బ్రాంజ్, బ్రాస్. బ్రాస్ ఈజ్ కాపర్ అండ్ జింక్. సో B3 కుడ్ బి దిస్. ఓన్లీ వన్ ఆప్షన్. ఒక బ్రాస్ తెలిస్తే అయిపోయింది, ఆన్సర్ వచ్చేస్తుంది కదా, అంతేనా? B3లో యూ హ్యావ్ గాట్ B3. So bronze is copper +tin. So bronze is copper +tin. And UK silver copper +nickel. UK silver coin. Actually ఇది సిలబస్లో లేదు కానీ ఇచ్చేసాడు. స్టెయిన్లెస్ స్టీల్ కార్బన్